Hello everyone, welcome to my talk. Well, that escalated quickly, a penetration tester's approach to privilege escalations. But before diving into the topic, I would like to ask you some questions, and I would ask you to raise your hand if you think the answer is yes. So first of all, how many developers have we in the room? Wow, okay. How many architects, software architects? Good. Any network or system administrators, engineers? Great. Wow, okay, some hands. Any one of you a penetration tester? Okay, cool. Besides that, would you think that on your daily work you have more than 50% topics that concern the security of your product or the project that you're working on? Over 50%? Okay, some. As we're going to talk about local privilege escalations, how many of you use Windows as a native operating system? Okay, some. How about Mac OS? How about Linux? Okay, the majority Linux, but still some Mac OS and some Windows users. Another question, how many are your computers encrypted with a disk encryption tool like? Okay, most of you, that's good, because we're going to talk about some attacks against disk encryption and missing disk encryption especially. And the last question, how many of you have ever written or read a penetration test or penetration test report? Okay, most of you. So this talk is more from an attacker perspective, not from a defense perspective, just because we or most developers mostly just get these reports and then they know, oh fuck, I have to do a lot of things, I have to fix a lot of vulnerabilities, and mostly they do not see a penetration test as something beneficial, but instead something that disturbs their daily work. So we want to we want to escalate our privileges. Why do we even want to do that? From an attacker perspective, when we attack or penetrate systems, we usually attain low privileged access to a system. So we are able to connect to a Windows server or a Linux server and have a low privileged user. But to be fully operative, we do need the highest privileges possible. So we need root privileges or administrator / system privileges on a Windows system. So escalating privileges is a very important task, but in the same time, it's very complex. Sometimes it's easy, but most of the time, it's a very hard process, and you have to be very creative and know many different tricks. So why did I choose this topic? I wrote my master thesis on this topic, privilege escalation, because I found during my daily work or my daily penetration tests that there are some articles about privilege escalation, but I didn't find a literature that really profoundly and comprehensively deals with this topic. So the main goals of this talk is first to have a deep understanding of different privilege escalation attacks and concepts. So we will mainly focus on Windows, but many of these concepts can be also applied to Linux. And for the penetration testers within us, this talk will give you a practical and systematic approach on how to really escalate the privileges. So first, some words about about Windows and its components. So Windows is mostly used in company environments, especially as employee desktops or laptops, and it holds a total market share of over 80%. So yeah, it's the biggest operating system, so to say, in regards of desktops. Nowadays, Windows servers are also very often used, especially in the times of Outlook and Skype for Business and so on. And Windows contains a number of different mechanisms, concepts, which are very often complex, but are required to be understood in order to escalate our privileges. And our goal on any Windows system, if we try to escalate our privileges, is to acquire administrator or system privileges. So one very important component, of which most of you will have probably heard of, is the registry. So the registry is very similar to a database, or it is a database in fact. So it is composed of keys and values, and every key can have subkeys. And the values of these keys and these subkeys either have values themselves or further subkeys. So we have a we have a tree architecture. The highest level keys are called root keys, and they contain information on the system, boot and system information. They contain software settings. They contain the security database, like passwords are stored in the registry, and also there are different per user configuration settings. So if you have different users on a system, every user can have his own settings. And the registry itself is protected by an ACL, so you can define, or every key has an ACL, and some may have wide permissions and some may have very restrictive permissions. Another very important component are the Windows services. What is a service? A service is a process that is started at system startup. What it does, it executes a service executable file, and it may also execute configuration files or similar files. Most systems, if you now look at your own PC, for instance, will be tied to the system user. However, it may be possible that they are also tied to interactive users, which is a better practice. It's not necessarily a better practice, but it shouldn't be tied to system at least. Yeah. Also, we have startup programs and scheduled tasks. These are very similar to services, so we do not have to explain too much about them. The startup program start an executable file at system startup under a certain user, and scheduled tasks execute a file on a specific if a certain amount of time has vanished. Yeah, so these were the most important Windows components that we need to know about. Now diving a little bit into some privilege escalation methods and techniques. As a short overview, there are components that are very similar, as we have just seen. Services are very similar to startup programs and scheduled tasks. So there are some techniques or methods that could be applied to all three components. And in the next slides, what you will see are attack trees. They contain all the different attack possibilities for a certain component. So the first one are insecure services. And as you can see, if we want to attack insecure services, we have 5 different possibilities. We could first of all search for a weak service executable or configuration file. We could search for unquoted service paths, which we will talk about shortly. We could have weak service permissions. We could execute a DLL hijacking attack, or we have weak registry key permissions. And every attack may have other requirements or constraints. So this is what is an attacker used for, to facilitate and give a good overview of different attacks. Just to dive into some of these techniques, the first one is a easy to understand technique, where we try to find a service executable that has weak permissions. So for instance, if we have a service that is started every time you start our PC. Let's say we have a sound manager program and it's a service, and every time the PC starts, it tries to execute a certain file. So this is exactly what you can see in this picture, in this blue picture. Sorry. Here, there was a program called Waves this svc64.exe. This was a program that was shipped with my previous laptop, a Dell laptop. And as you can see in the screenshot, this is the output of a tool, of a hacker tool that I've used. And as you can see, modifiable file identity reference built-in users, and these are, and all users that belong to this group, called users, are able to modify this file. And beneath that start name, we have local system, which is the system account. So what we could do here, just easily replace the executable file with our own file that gives us administrator privileges or that executes a certain malicious method that we want. So yeah, this is one possibility. Another possibility, and I find it quite interesting, is called unquoted services path. So as I said, every service has a executable file that is run when the service is started. And the path to this service executable file is defined in the registry. If this path does not have double quotes at the beginning and at the end, and contains white spaces, then Windows behaves a little bit weird. So what it does is it tries to find the first white space. It looks where the first white space is and tries to run the program where the white space is located. As an example, so that we understand it, we have C program files, and here we have a white space, /waves, /max audio, /waves sys svc 64.exe. Now, at the first white space, what does Windows do? It tries to execute program.exe. So for this attack, what we have to find is such an unquoted services path, and we need write permissions to the certain folder. So in this case, it would be C. If we have write permissions to C, then we can place our own program.exe, and the next time this service is executed, we will our malicious file will be executed with the services privileges. And yeah, this was actually the exploit that was shipped with every Dell laptop, I think, 1 year ago. And not only Dell had this problem, but also ThinkPads and Lenovo. Lenovo with its ThinkPads. Another, a little bit more complex technique is called DLL hijacking. So DLL are, in simple terms, are libraries that are loaded by a program during a runtime. And if such a DLL file is or if a program tries to load a DLL file with a relative path, what Windows does is that it tries to find this DLL. What does it do? It first of all tries to find it in the directory folder where the program itself is located. If it doesn't find the DLL in there, it searches in Windows System 32, then in Windows System, then in Windows, then in the current working directory, then in directories in the system path environment variable, and then directories in the user path environment variable. Meaning, if you have a program that tries to load a DLL with a relative path, Windows goes through all these directories and searches for this DLL file. And if the DLL file itself is missing, and we are able to write to one of these directories, what happens is that the program loads our malicious DLL file, and this will be then executed by the program. So for the first 5 directories, we would normally not have any write permissions. However, for the system path environment variables, there is a possibility that we have write access or write permissions to one of the folders in there. So yeah, this is a very interesting technique which can be, I would say, widely found in the nature. Yeah, so these were 3 different methods on insecure services. And this is, again, an attack tree for insecure startup programs. And as you can see, we have the same attacks. We have the weak startup executable or configuration file permissions, weak registry key permissions, and DLL hijacking. So the same applies for insecure startup programs and also for insecure scheduled tasks. One interesting thing about scheduled tasks is, or at least for the services and the startup programs, what you would have to do is to restart the computer so that the service is executed. For the scheduled tasks, you will have a defined time on which the task is executed. So if this time is very far in the future, what you could try to do is to change the system time to that exact time so that the task is then executed. You will not always have the permission to do that, but you might have. So I think that's a good tip. Another very obvious thing, but I would say this is probably the thing that is used for most privilege escalation attacks, or where most privilege escalation attacks were successful, is outdated software. Be it the Windows kernel itself, or be it some software that runs with high privileges that you can then exploit. Why is this even possible? First of all, Windows kernel exploits and also normal software exploits are found and published in a frequent manner. So maybe between each exploit you will find, Windows kernel exploit, you will find a time gap of 3 or 6 months. And companies have to deploy these patches in a timely fashion. However, if you have a very large company, or if you have very critical systems that you cannot just deploy the patches on, but first of all have to test the patches, then there's sometimes a time gap where the exploit would be still successful. And yeah, every kernel exploits results in system privileges. And I think there was just recently again a new kernel exploit where you were able to modify any DLL file in the Windows folder. Yeah, so this is a very good point. Another thing is weak passwords. This is also very obvious, but I'll tell you a story after this. So first of all, weak passwords can be guessed, can be brute forced in certain environments, and we may be able to find configuration files or other files that contain passwords. For instance, you have a Linux server that runs a web server, and this web server connects to a MySQL database. Somewhere on this server, there is a MySQL password. And if your administrator uses the same password to connect to the MySQL database and to log into his root account, then we will have a very easy privilege escalation. And once in an assignment, I had the task to check the employee laptops, whether an employee would be able to escalate his privileges from a low privileged user to an administrator user, which the company didn't want, because an administrator can install everything that you want. And I found a password in a configuration file, and this password was not only used for a local administrator user, but for the domain administrator. This means, with this domain administrator, you would be able to connect to any laptop of this bank, including the the CEO, including the administration, and so on and so forth. So very, very low-hanging fruit. And actually, I was searching and trying the harder methods, and I think it was like on Friday, the last day of the assessment, where I tried those easier things, and look what I found. Another interesting thing is about physical protection, or physical access protection. So I asked you, is your volume or is your partition encrypted? And most of you answered yes. Why is this important? For instance, in Windows, what you could do on a non-encrypted volume is that you can boot your own Windows CD, replace certain files on the victim PC, and then the next time you start the PC, you will just click on this easy to access icons in the login screen, and then you will get a shell. And with this shell, you can do everything that you want. The same attack can be applied on encrypted partitions. However, it is more difficult, because what you will have to do is, so the first requirement is that there is no pre-boot authentication, meaning that if you start your PC, you are not required to type in your password. And if this is the case, and you have a boot option like USB or network devices, then I could start my own. I could put my own operating system on the USB stick or on my network machine, which then your machine will boot from, and then I will try to get your memory, dump your memory from your PC, where the decryption key will be stored by the encryption software. And with this, I could then decrypt your volume or partition, and then again fulfill or perform the first attack that I talked about. And also what is possible, as you all have heard about Spectre and Meltdown, there's the possibility that I can also attack your CPU microprocessor or microcontroller. So coming to our privilege escalation approach, and we don't have too much time, so this is the overview of the approach. In the first phase, you have a general information gathering phase, where you try to find out general information about the system. What operating system is it? What architecture does it use? And so on and so forth. So general information about the system. In phase 2, what we will do is we iterate through all the different privilege escalation methods and techniques. And this contains, again, 4 steps, which we will cover shortly. And in the last phase, we will report the vulnerabilities to the customer. So in phase 1, as I said, we will try to gather general information about the Windows version, the services that run on it, the network devices, and so on. At the end, we want to have a good overview of the system. What does it do? What does it contain? In phase 2, there's an iteration through all different methods and techniques. And accordingly, on the pentester's objective, we could first of all try the weakest methods and techniques, or we could start with the more complex ones. This is dependent on the pentester's objective, whether it is his objective to find as many privilege escalation methods that are successful, or whether his goal is to just escalate privileges and then from there try to get access to other systems. There are 4 steps. The first step is the information gathering step. So if we have a certain method, like we try to find out whether there is a weak service executable file or a file with weak permissions, then we would first of all try to find a weak service file. A service file with weak permissions. So this is meant with step 1. Step 2 is the research and development step, where we again find out about available exploits, how they work, and how we can customize these to our certain system. Sometimes there are exploits that either work or crash the system. For such exploits, it would be the best advice. The best advice would be to set up a test environment where you can test your exploit. And whenever you have an exploit, before executing it, please try to understand it, try to understand what the code does. In step 3, we try to exploit we try to perform the exploit. Sometimes we are lucky and it works on the first attempt, but in most cases what you will then have to do is to again find out why it didn't work, why did it fail, and then again go back to step 2, which is research and development, and then again try it out. And in step 4, we have the post-exploitation step, where we document what we have done, whether it was successful or not. And what is also very interesting for many companies is to find out, hey, did the antivirus software detect the exploit? Or hey, did the ZM create an alert? Then we have the reporting phase, where we report every vulnerability that we have found, independently on whether it was successful to exploit or not. Sometimes you just need a little bit more time, but you don't have it, so you should at least report it, that the customer can think about it and maybe even fix it. Yeah, whenever you write your report, please censor the passwords and any sensitive data that you have found. And yeah, in case you have found out that there was already another one, someone else on the system, an attacker, an external attacker or something like that, immediately contact the customer. Yeah, everything that you have changed on the system should be documented so that the customer can then again remove added users or remove unnecessary files. So this was the penetration tester's approach. A very short glimpse on some tools that facilitate this approach. So the most famous tool is Metasploit, probably. Metasploit is very, very comprehensive and contains many different scripts, which you could use for information gathering or actually exploiting different things. Also Powersploit, which you can also find on GitHub. It's an open source project. Beroot is a nice tool that which you will just execute, and it tells you, hey, I found this service executable file with weak permissions, or I found this unquoted service path, etc., etc. And the last one is the Windows Exploit Suggester, which tries to find out all patches that have been installed on the system and matches it with a database with the Microsoft patch database, so that it finds out whether all patches have been applied or whether there are missing patches. Yeah, let's come to the conclusion. Half a minute left. So I hope we learned a little bit about Windows, about some privilege escalation concepts. We talked about this penetration testers approach on how to do that. And yeah, some tools have been introduced. I think the contents of this talk are not only beneficial to penetration testers, that's why I asked the question I asked in the beginning, but also to developers that build software, Windows or Linux software, so that they can check whether, hey, is the service really secure or not, for instance. And especially by system administrators that have to administrate Linux or Windows systems. Generally speaking about Windows systems, as this was the main topic, I would say Windows, contrary to many beliefs, offers a great number of different security mechanisms. You have a very fine and granular ACL that you can define for files or for the registry. And typically, Windows patches security vulnerabilities in a timely fashion. That's it from my side. Let's come to the question and answers. That means all questions have been already answered. That's good. All right, doesn't look like there are any questions. In case you have any questions in the future, these are my contact details. There's a question, yes. Okay, your question was, as you didn't have a microphone, I'll just repeat it. If you have access to a system and you have found a file that you want to modify, but it has restrictive file permissions, you're asking whether it's possible to still modify the file? Okay, so if you still want to modify the file, that would mean either you find a vulnerability in the Windows mechanism of the ACL file, which I would say is very, very unlikely, especially if you have an assignment or a project with a limited time frame. Besides that, which you could try to find out whether there's a vulnerable service that runs or process that runs with high privileges that you can use to write things to a certain file. This is maybe the only case I could think of that would, yeah, where you could exploit or bypass the ACL file. For instance, there was, or nowadays, especially with Windows 10, there is a new security concept called whitelisting, where you have a whitelist of all the software that is allowed to be executed on the system. Maybe some of you have heard of it. It's, you can also find it for Linux and so on and so forth, but now with Windows 10 it comes shipped with the operating system. And for instance, one very easy bypass for this is to run another program that is whitelisted. There are some different programs that already come shipped with the operating system that again execute another program, where you can give a parameter or which you can use to execute another program by just providing the path to the other program. And by this, you would easily bypass the whitelisting mechanism of Windows. That means you have control. That again, your question is, as maybe not all have heard it. If you have access to this program, which you can use to execute other programs, then you have bypassed the whitelist. That means you have execute permissions on the whitelisted program, yes. And this is a bypass for the whitelist, so to say. Let's say you have program A, which is whitelisted, and you have program B, which is not whitelisted. Thank you. So what happens is that you execute program A, and with program A, which is whitelisted, you execute program B. And as processes are inherited, what happens is that Windows allows this mechanism, or allows you to execute program B with program A, because it's beneath program A.
Okay. Oh.
Now we hear you, great.
But if you can say to the program A, okay, I want you to execute program B, it means that you already can do a lot of stuff with program A.
Okay, not necessarily. There are programs that contain this functionality, or that contains a function to execute other programs. So it's not necessarily that you have modified something on this program or something like that.
Okay, thank you.
Yeah. You're welcome. Any other question? All right. Then, as I said, if you have any questions, you're very welcome to contact me. We are hiring smart and enthusiastical people that are curious on security topics. So just come forward to me. Thank you all.